All right, welcome back. This is chapter 6, section 5, entitled Graph, Square Roots, and Cube Root Functions. To begin with, radical functions. What are radical functions? Well, a radical function is a function containing a radical. So a function would be something like f of x, an equation that is equal to something that has any form of radical, the square root of x, or f of x equals the cube root of x, and so on. All right, so it contains a function that contains a radical. All right, now parent functions for square roots and cube root functions. All right, what this means, we've had parent functions for a long time. We've had a parent function that is y equals x. We've had parent functions that are y equals x squared. We've had parent functions that are y equals x cubed. All right, these all have a certain look. So the y equals x is a straight line that goes through there. Y equals x squared is a parabola that goes through the origin. Y equals x cubed is a cubic function that goes through the origin. These are what all of them start with. So this parent function, the parent function for the family of square root function, the domain is x greater than or equal to 0, and the range of y is also greater than or equal to 0. What this means, we've talked about domain in the past. You cannot have a even root of a negative number. So what we've done in the past when we've said like x plus 2, all right, this is a child function of this parent function. So we've just said that this is greater than or equal to 0. The domain then changes to be that. This is how this is set up for the domain and range. Parent function, the square root of x, and the domain and range are all greater than 0. The book may say non-positive integer or non-positive real numbers or something like that. Inequalities are fine. The parent function for the family of cube roots functions of a cubic, the domain and range are all real. This is the symbol for real numbers. Okay? You don't have to write out the word numbers, just put the numbers in. So whenever you see a cubic or a 1/3 power or a 1/5 power or a 1/7 power, those are all real numbers. So um, let's actually write that down. So for domain and range, for an odd root or an odd radical or an odd denominator for the exponent, it's all reals. If you have an even rad or an even denominator, you're going to basically say that x is greater than or equal to 0. It's not really always 0 because of this example, but it's whatever the rad is, that thing has to be greater than or equal to 0. So let's look at the table. Graph y equals 2 square root of x and state the domain and range. Compare the graph with the graph of y equals square root of x. So y equals the square root of x has a point at the origin, goes through here, and then goes through here. So it looks like something like that. You could graph this on your calculator if you'd like. Now, make a table of values and then sketch. This is fine. Use the table of values. Use your calculator to sketch the graph if you want to. But what you're going to do, and I personally would probably use the calculator. I would go into the y equals menu. I would put 2 square root x. And instead of hitting graph, use second graph. And this will bring up the table. Right away, when you hit second graph, the table will show up and 0 will be 0. X is 1 will go to 2. X is 2 will be about 2.8. X is 3 will be 3.46. And when x is 4, it'll be 4. So now go ahead um, and graph this. It goes through the origin. Let's see, 1, 2 is nice. And then 4, 4 is nice. So basically our child function is this. Basically what's happened is it's taken the parent function and straightened it out. All right, so that's how you can graph this, just by looking at the table. The radicand of a square root is always non-negative. So the domain of x, remember, greater than or equal to 0. The range, remember from over here, greater than or equal to 0. So the question then, how does it compare? Well, if you just graph this, if you push then graph on your calculator, you'll see this exact same graph, and you'll see that the parent function had a vertical stretch. Right? It took this point here and stretched it out to there. That's how this is set up. All right, now graph a cubic. Right away, when you see a cubic, okay, remember back to here, it says odd rads or odd denominators have all real numbers. So the domain range, you get to just say all reals. Should make you smile when you see that. You're going to put it into the y equals, and then push second graph to bring up the table. And when you see that, you'll see that, let's change the color, you'll see that negative 2 maps out to be 0.63. We'll just say 0.6. Negative 1 becomes 0.5. 0 is still 0. 1 is negative 0.5. 2 is negative 0.6. And so we went from a graph from the standard graph, which is this one right here. Your real graph, your original, your parent function should look like this. Oops, I don't know why I'm using red. Should look like this. Okay, that's your parent function. Okay, I'm going to erase this. The parent function, like I said, should be something like this. And then now for this next function, 0, 0. At negative 2, it's 0.6. At negative 1, it's 0.5, 0.5, 0.6. So your new function should look like that. There you go. All right. So the question is, how does it compare? Well, the graph of this is a vertical. Instead of a stretch, it looks narrower, doesn't it? So we would call that a shrink, a vertical shrink. It's getting squashed a little bit, and it's by a factor of 1/2. Now, not only that, the other difference is also that it's reflected over the x-axis. Right? I'm looking for, can you tell that it's a shrink? Can you tell that it's how much it maybe got shrunk by? Maybe even if it got shifted over left and right, which might be an example here in a second. So let's move on here to some more examples. All right, 2 cube root of x. So domain range together for a cubic, all reals. Now, if we did a table of values, and you wanted to use your calculator, you would put y equals this into your calculator, hit second graph to bring up the table. Now, when you bring up the table, when you bring up the when you bring up the table for this, let's choose like I guess negative 4, 0, and 4. Okay. When you choose negative 4, it ends up being approximately negative 3.1 or 3.2. 0 is 0, and 4 is positive 3.2. So on your graph, you've got 0, 0. You've got negative 4, 1, 2, 3, 4, 1, 2 point, 3 point, what was it again? 3.2, so 1, 2, 3.2. Negative, sorry, negative 3.2. This one over here is positive 3.2. And what you've got is a graph that looks something like that. It's not a very good graph, but I'm having trouble graphing it today. So, actually probably more like that. There you go. Okay. So there you go. So graph looks something like this. And that's it. This one here. And if you want, we're asked how was this changed from its parent function? You would see that it was stretched, and that's pretty much it. It had a vertical stretch. All right, the second one of these checkpoints, you're doing negative 2, the square root of x. And when you look at the table for this, you'll see something. Let's look at the table. Let's try a negative 2. Let's do 0. Let's do 2. When you look at the table, you will see that comes up with an error here. And that's 0, and that at 2, it's negative 2.8. All right. The reason you get an error here is because this error is out of the domain. Negative 2 is not part of the domain. You cannot take the square root of a negative number. So what that tells us is this graph starts at 0, 0, and then goes up to negative 2.8. So 1, 2, 2.8. So you have a graph that looks like this. It is a stretch. It also got flipped over the axis. So we graphed it. You could graph this on the calculator by hitting just graph. But now for the domain and range. Looking at this graph, the domain is x is greater than or equal to 0. You can see that. Look, it starts at 0. It's going towards x in the positive direction. So it's x is greater than or equal to 0. The range now is a little different than what we talked about back here, where where it's greater than 0. The reason it's different is because of this negative. This negative changes the range. Starting at 0, 0, do we go up to the positive y's or down? I hope at this point all of you know that this is down. And you can then say that those are the negative y values. So y is less than or equal to 0. That's how you look at the graph to come up with the domain and range. Now, as usual, we're going to do some of the guided practice. I'm not going to do all of them. I'm probably going to do 1 and 4 or something like that. Number 1 tells you to graph and state the domain and range for negative 3 square root x. Well, let's graph it. In your graph, negative 3 square root x, when you graph it, you'll see that for the table of values, once again, anything less than 0 gave you an error. 0 was 0, and at 2, you've got negative 4.2, about. So that means we've got 0, 0, 2, 4. You got a graph that looks like this. So what is the domain? Even looking at the table, looking at the graph, you know that x has to be greater than or equal to 0. Looking at the range, it goes down from the origin, so it's less than 0. Take a look at number 4. This time you've got 4 times the cube root of x. 4 times the cube root of x. If you look at the table of values, and you put this in here, you'll see that you don't come up with any errors. There are no errors. That's because, put negative 2, 0, 2. That's about 5, 0, negative 5, 0, and 5. So when a graph goes through 0, negative 2 is 5. It should look something like that. Cubics should make you happy because it is all real numbers for the domain and the range. All right, so that's some of the guided practice. All right, now that's for simple changes to the equation. We are just multiplying by a scalar. You now have right here. This is a standard form for cubics and not cubics, for cube roots and square roots. Step 1 should be to sketch the graph, okay, just like we've been doing, and then talk about how you translate the graph h units horizontally and then k units vertically. This number right here refers to the range. This number right here refers to the domain, helps you with the domain. So let's just talk about this. I'm going to give you some things that your notes don't have. You may want to put this on the side under the Your Notes category on the left. When you have a square root x minus h plus k, the domain is what makes this equal to 0. So the domain is at x minus h greater than or equal to 0, because you cannot have a negative number inside there. So that's how you set up the domain for all of this. The range is a two-parter. First, you have to look at a. If a is positive, then it's simply that y is greater than or equal to k. If a is negative, all you have to do is that y is less than or equal to k. That's it. That's how you find the domain and range for a square root. Mind you, I said only wrote a square root. This is only true for squares, for square roots. That's because you all should know for cubics, it's simply all real numbers. So we'll refer back to this in a little bit. All right, so let's graph the first one. Graph this, then state the domain and range. All right, sketch the graph of the parent function. Notice that it begins at the origin and passes through the point 1, 2. All right, that's because it's the starting point. H and K are the starting points. The starting point is at HK. Remembering that H is what makes x minus H equal to 0. So the starting point, 1, 2. Translate, let's see here. Translate the graph for this. H is 1, K is 2. So shift the graph up, right 1, and up 2. The resulting starts at 1, 2. and passes through. Oh, okay. Let me refresh. Let me refresh this. Actually, erase this. I'd start over, but I'm already about 20 minutes in. Um, this isn't 1, 2. What this graph here is asking you for, this is saying put 1 into that x. So 3 square root of 1, that's 3 times 1, that's 3. So the parent function goes through 0, 0, and 1, 3. So this is the parent function. You don't have to actually graph the parent function. Now what it's asking is right here, you shifted the starts at 1, 2 because we shifted from 0, 0, right 1, up 2. Then this point, 1, 3 also shifts. 1, 3 goes up, right 1, up 2, and is now right here. So now this graph looks like that. So now it passes through 2, 5. 2, 5. All right. Sorry for that, but the next part here is going to be domain. This is a square root. So the domain, x minus h, is greater than 0. So x minus 1 greater than or equal to 0. That means x is greater than or equal to 1. The range, right, look at A. A is positive, so we're looking at this. Y is greater than or equal to k. Therefore, y is greater than or equal to 2. Here's the domain and range, and here's the sketch of the graph. We'll do some more here as well. Take a look at this. So it's telling you to sketch the parent function. You don't actually have to if you don't want to, but it is good to see. You'll notice that the passes through the origin and the points blank and blank. So what you're going to do is you're going to see that when you take this and you graph this into the table of values, you'll be given some points that you'll need to. All right, so you'll see that it goes through the origin. You'll see that it goes through -2, -4, and oh, I'm sorry, I'm looking at the wrong table. So when you graph, so rephrase this. So put this y equals into the calculator, do second graph to come up with a table, and you'll see that -1, 2, and then 1, 2, and the origin. So -1, 2, and then 1, -2, and you'll get a graph that looks like something like that. That's the parent function. All right, so now you are going to graph this actual function. You're going to graph the actual function by putting into the calculator, looking at the fact that the h value, the starting point is x plus 3 equals 0. Therefore, x is -3. So h is -3. K is just simply the -2. So that's one of your points. So -3, 2, -3, -2. So -3, -2 right here. That's the origin got shifted. 1, 2, 3 left. And 2 down. And now you have some extra points there. Let's use 0. It's about, you got about 0 and about 5. You've got the origin already at -3, -2. 0, 5 is down here. So basically your graph looks exactly the same except shifted a little bit. All right. Sorry for any confusion here. We'll get the next one perfectly. Cubics make you smile because the domain range, all reals. All right, let's get moving here. All right, let's do some checkpoints. I'm not going to graph the parent function for these. We're going to start by the fact that this is a square root. So that means the domain is at x plus 3 greater than or equal to 0. Therefore, the domain is x greater than or equal to negative 3. The range is just simply looking at a. Since a is negative, we change this to y is less than 2. We've got the domain and range thing down there. All right. Now, we also know that hk is one of our points. So you look at the domains, negative 3, 2 is one of our points. Negative 3, 2. We need a couple more points, so I would suggest typing this into your calculator and solving. If you put 1 in there, that's a square root of 1 is square root of 1 plus 3 is 4. Square root of 4 is 2. Negative half of 2 is negative 1, 1. So I guess it's 1, 1. And work on a couple more. All right. Now, since it's a square root, this right here is our starting point. And then all you really need is to just draw your graph, something like that. All right? There you go. Cubic square roots are easier to graph, but harder to find the domain. Cube roots are easy to find the domain and range because it's just all reals. But now graphing it can be a little tougher. They all share the point hk in common. So here, h is 1, k is 2. 1, 2. Oh, I'm sorry. 0, 2. 0, 2. Because what makes this equal to 0 but 0? 0, 2. And let's see here. Let's put a 4 in there. 2, 4. Oh, no, not cubed. Let's put it into your graph. And you should end up with a graph that looks like this. So we put this into y equals. We graphed it, found some points, said the domain and range. All right, guided practice. Let's take a look at some of the next guided practice. We're again not going to do all of them. Let's do let's take a look at number 7. Number 7 is y equals 2 square root of x plus 1. All right, let's start with the domain. You say x plus 1 greater than or equal to 0. Therefore, x is greater than or equal to negative 1. Range is what's being added on, nothing. So y is greater than or equal to 0. A is positive, so that's why we use a greater than. So good. We already have the domain and range done. Time for graphing. Graphing it, you should just go ahead and use a sketch from your calculator, but you should at least try to find the fact that it starts at hk. The starting point is negative 1, 0. Negative 1, 0. Right there. That's the starting point. And now a second point somewhere, put a 0 in here, square root of 1, 2, it's 2. So here's what your graph. Whoa, that's a bad graph, but the work is good. Should sketch out to be something like that. Let's take a look at number 10 from your guided practices. Y equals the cube root of x minus 5. Please notice the minus 5 is outside of the radical, so you have to make sure to know it's not being a cube root. So this is the k value. So hk, what makes the inside the radical equal to 0? 0. What's being added or subtracted? Negative 5. So I already know my first point. The domain range you should be happy about because it's all reals. And as far as graphing this, we know that 0, 1, 2, 3, 4, 5, 0, -5 is a good choice. And when you sketch this in the calculator, you should get something that looks like this. Okay? All right. So that's pretty much it. You should be able to rewatch these and get an idea of how to do all the practice problems, finding the domain and range, graphing it using the table, using the calculator graph function. You should be all set for that. Good luck.